Hey guys, so in this video, I'm just going to be redoing the last problem I did on the isomers video, and this is essentially a very similar problem to what she does on her exams. And I'll actually be doing two different types of isomer problems that are pretty common. The first, for this problem, the problem is asking us to mono, let me just do this over again. It's asking us to monobromination of this carbon chain, okay? And so monobromination means attaching a single bromine to anywhere on this carbon chain that has free hydrogens. So everywhere that has free hydrogens, right? This has 3 hydrogens over here. This has hydrogens. No hydrogens. I have hydrogens over here, right? So you get the point. Anywhere that has free hydrogens, I can brominate at that location at least once. And it's only brominating one time, so we don't have to worry about multiple bromination at a single location. We're just brominating once. And what she wants us to do is draw all the isomers that result as a result of monobromination. So there's many isomers that can be made because I have many sites where I can brominate. So she wants me to draw all those different forms of the molecule. So the first thing we have to do is we have to find unique environments. So what I always want to look for first is, aside from finding, where I have hydrogens actually, I need to find if I have any planes of symmetry. So right here, I realize I have a plane of symmetry that cuts right through this molecule. And maybe I should draw it like this. I've done that. All right. So plane of symmetry right here. And now now the only thing that tells me is that this half of the molecule is the same thing as this half. So that's important when I'm trying to find unique environments to add my bromines to. So I'm labeling every unique environment. So there's A, B, C, and D. Okay, essentially a unique environment is a carbon that its environment is obviously different than other ones on the molecule. So this B, I don't have another carbon environment that is exactly the same aside from this one right here, right? So this is also B, this is also C, this is A, and this is also D, right? So now I just need to brominate. So I'm going to start drawing the molecule, right? I have 4 unique environments, so I have 4 isomers that I can draw. Okay, so first one, I'm just going to attach a bromine right here. The second one, I'm going to attach a bromine right here. Third one, I'm going to attach a bromine right here. And fourth one, bromine right there. And then I'm done. And then just put a box. Okay? And that's all the isomers. Isomers just, they have the same chemical formula, but just different connectivity. Here, these would be structural or constitutional isomers. And that's actually said in the actual problem instructions. Didn't feel like copying and pasting it here. So this is this problem, and this is what the answer would be. A different type of problem would simply be, she would say you have this formula, so she'll say you have like C6, and then okay, so C6, E6, then 4, so I have C6H14, I believe. And so she would say you have this chemical formula, and she'll say draw all the isomers for this molecule, okay? And so the first thing that you should do is just draw out this molecule as if it were a straight chain. Okay, so 1, 2, 3, 4, 5, 6. Okay, all right. So that's what we have. And let me just make sure I have the right number of hydrogens. So there's 3 here, that's 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I have the right number of hydrogens, just making sure. So she'll give you the formula, and she'll say, draw all the isomers of this. So I already drew like the first thing that you're gonna put down, right? That's the basic one, just back to back to back. Now what you do to draw the others, right? This is just gonna be a bunch of structural isomers, or have different connectivity of the carbons. And so what I'm gonna do, I'm gonna chop off one of the carbons. Okay, so I'm gonna decrease the straight chain by one. So I have 3, 4, 5 now. And then what I'm gonna do, I'm gonna take that piece that I took off, and I'm gonna add it. Okay, I'm gonna add it. All right, so now I just drew another isomer, right? It has the same number of hydrogens, same number of carbons, just different connectivity. And now there's another version of this, right? So now I'm going to draw all the isomers that correspond to this. So another one would be right here. Now the question is is this another one right here? This is not another one, right? So if you see this, it has a plane of symmetry. Before I drew this, it had a plane of symmetry. So my unique environment, right? Each time you kind of have to consider unique environment. I'm doing it in my head, but if I was just looking at this, right, in the beginning, draw symmetric along this point, and then I have a unique environment right here and right here. I'm not going to add a carbon here because essentially that would just give me the first thing. So the only thing that I have to work with is this one right here, and so I add it there, and then this one right here, and I add it there. Okay, this is the same exact thing as this one. So if I was to label all the unique environments, this would be A, this would be B, this would be C, this would be B again, this would be A. Okay, just for those of you who are having trouble with finding the unique environments. All right. So I'm going to delete that one and move on to the next one. So I've drawn all the unique environments, added all the positions I could for a 5 carbon one, and then adding the methyl group. Now I'm going to decrease it again, and now I'm going to add 2 methyl groups. So I have 4 now, and now I have 2 methyl groups to add. So I'm going to add 1, 2. Okay. Can I do anything else? Can I put them in any other positions? No, you can't. All right. And basically we're done now. So if I go to 5, right, if I make it 3 carbons long and I have 3 things to work with, okay, that's all I could do. I could add a methyl group to each point or whatever. Essentially you'll start getting the same things that you've already drawn before. So this is this one. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then in the middle, right? So I believe these are all the isomers for this molecule. Okay, so this is just another example of how to do an isomer problem. All right, that's it.